All right, so I'm here to explain mainstream of Northwest Regional Mock 2025 Physics Paper 3. Let's go. So you are provided with a capacitor, a battery, two small dry cells in a battery holder, a fixed resistor a stopwatch, connecting wires, and four crocodile clips. Now, if this video is not clear on your device because this is on YouTube, make sure you increase your resolution power. If you don't know what they call resolution power, just search on YouTube how to increase resolution power. They will show you. You take it to either 360 or 720 because I'm actually recording the screen of my phone, so this video might be blur on your device. So if it is blur on your device, make sure you increase your resolution power so that you'll be able to see clearly what I'm going to be explaining. All right, so in a mainstream, I basically read it and we are actually discharging a capacitor, okay, via a resistor. So let's go. By number one, first instruction, by using the multimeter as an ohmmeter. A multimeter is an instrument that measures many things. That's why it is multi. So you could use it to measure voltage. That's when it is used as a voltmeter. You could use it to measure current. It is used as an ammeter. You could use it to measure resistance. It is used as an ohmmeter. Okay. So by using the multimeter as an ohmmeter, measure the electrical resistance arrow of the fixed resistor. So all you have to do is, if you have your resistor, let me just try to give a little demarcation. Okay, so this is not important. So if I have my resistor like this, in the lab you see a resistor like this, you have something like that, you have something like this with some lines there, and then you have another end like this. So this is how a resistor looks like. Okay, so what we actually do is that if you want to measure the resistance of this resistor using the multimeter, you need to connect the multimeter across the ends of this resistor. Okay, so I connect my multimeter across the ends of this resistor. Okay, and then I go to the voltage, to the ohmmeter section so that it reads the resistance. You know how a multimeter looks like. Or can I just try to draw? Let me just try to draw. So in a multimeter, I think you have a certain box like this. You have a screen there. Okay, you have a certain arrow here. You have a pointer here to tell you. Then you have some two holes here where you have some cables leaving. So what you do is that you take the first cable, connect it to this side, take the second cable, connect to this side, and automatically you read the value of your resistance on your screen. But you need to make sure that this pointer is pointing in the section of resistance of ohms. Okay, then you record your resistance as arrow. Are we there? Now for the capacitor, a capacitor, if you want to draw the circuit symbol, is just two parallel lines, okay, or two parallel lines, vertical or horizontal. Okay, but now in the lab, the physical, that is the capacitor itself, is just a small kind of a little cylindrical something, okay, little cylindrical something, and then it has two wires pointing out of it. One is short and then one is long. Okay, and then the short one is a negative terminal and the long one is a positive terminal. Okay, now the value of the capacitance is written on the capacitor itself, so you just have to go through the capacitor. You are going to see the value of the capacitance, and it is in microfarads. So when you're writing your value in the hall, don't go and write times 10 to the minus 6 farad. No, you do not see times 10 to the minus 6 farads. You saw a value in microfarads, so you need to write it as microfarad. That's why we call raw data. Okay, so basically that is it for the first part. You record your resistance in ohms or in kilo ohms depending on how you measured it, and then you also record your capacitance by just looking at the capacitor and writing down the value. So I'm going to wipe this diagram and we move to the second instruction. Okay, so in the second instruction, according to the second instruction, what do we have? It says that connect the positive terminal of the capacitor to the positive terminal of the multimeter. Okay, now I have said that the positive terminal of the capacitor is a long terminal, because the capacitor we have two wires, like some two extension wires. Okay, one is short, one is long. The longer one is a positive and the shorter one is a negative. So we need to connect. In fact, let me just try to demarcate what is happening. So what we do is that maybe if this is my capacitor here, for example, right, and then I have one little terminal here. In fact, the thing is that the two terminals are actually on it. It's kind of the width. So okay, so let me just say that let me just say, okay, I have my capacitor here, for example, right? I have a short terminal and I have a long terminal. So what do I do? Connect the positive terminal of the capacitor to the positive terminal of the multimeter. So maybe this is my multimeter here, for example. Okay, this is my multimeter here. That is my pointer. That is my pointer there. These are the two holes. Okay, we know that you're going to know the colors, because the cables connected to the multimeter, one is going to be red and one is going to be black. So you take the positive terminal of the multimeter and you connect to the positive terminal of the capacitor. That is it now. So maybe the positive terminal of my multimeter, to positive of capacitor. So this is it. Okay, and then now what next? And the negative terminal of the multimeter to the resistor. So you have a resistor somewhere as well. So maybe let us say maybe we have the resistor here. Let me just put the resistor here. Okay, so this resistor basically has two ends, this one end, this another end. So what I do is that I take the negative terminal of my multimeter and I connect with what? You connect to the positive terminal of capacitor to positive terminal of multimeter, and negative terminal of multimeter. Okay, negative terminal of multimeter to the capacitor, to the resistor. The resistor has two extension wires as well, but now it has no polarity, so you can connect to any of them. So let me just decide to take and connect to this side. Okay, now the next thing to do is finally connect the free end of the resistor. This is the free end of the resistor here. Connect the free end of the resistor to the what? To the negative terminal of the capacitor. Okay, to the negative terminal of the capacitor. So I take the free end of the resistor, I connect it to the negative terminal of the capacitor through an open switch, and then I need to use crocodile clips for firm electrical contact. So using a switch, what I do is that I take a switch. Let me just give it blue. So what I do is that I take a switch. This is my switch. Okay, then I connect the two, you see. So then I put a crocodile clip here, and then I also put crocodile clip here. I put crocodile clip here. Okay, and then I also put another crocodile clip here. So these are the 4 crocodile clips that were given to me, so that for firm electrical contact, according to what the equation is saying. Okay, voila. So we are done with the first 2 instructions. Now let's go to the third instruction. It says that connect the battery across the capacitor. Okay, so let me just wipe these crocodile clips so that it does not disturb our diagram. So we need to connect the battery across the capacitor. So this is my capacitor. Okay, I need to connect the battery. Connect the battery across the capacitor. So I have I have my battery. Okay, let me just wipe this. I have my battery. Maybe this is my battery here. Okay, my battery has some 2 holes here, or some two things there. Now I need to connect the battery across the capacitor, and what are the instructions given? Let me take this color. What are the instructions given? According to the instructions, with a positive terminal on the positive terminal of the capacitor and a negative terminal of the capacitor to the negative terminal of the battery, and allow for 30 seconds. So I go to my battery. What I do is that I take, you know that the battery will also have a positive and a negative terminal. It depends the battery given to you. If it is those battery that you find in the calculator, then you also need to have the cables. Okay, so I take the positive terminal of the battery and I connect to the positive terminal of the capacitor. So I take positive terminal of battery to positive terminal of capacitor. Remember, there will be crocodile clips here, and the negative terminal of battery to negative terminal of capacitor. So that is it. So this is actually my connection. Okay, this is actually our connection. All right, that is actually our connection. Let me try to enlarge it. So this is our connection. Then we need to allow for how many seconds? For 30 seconds. Now number 4 says that remove the battery in number 3. So we need to remove this battery. Okay, then what do we do next? And set up the multimeter to the 20 voltage range, direct current range. So when you remove the battery, let me just remove the battery. Once you remove the battery, let me just put the battery there. I've removed the cables on the battery. Okay, when you remove the battery, you now have to turn your multimeter to the 20 voltage range. Okay, then what next do we have to do? Close the switch in number 2 so that the capacitor discharges through the voltmeter and the resistor. Oh, which means that initially the switch was not closed. So that's why it's always important to read all the instruction. So initially, this is our switch here. Okay, this switch, let me just say that the switch ends here. Okay, because they say an open switch, so the switch ends there. And then for us to close it, we just have to complete it like this. So initially the switch was not closed. Okay, the switch was open. Okay, so initially we just have to connect this guy like this and allow the switch like that. The switch was not closed. Is that it? Let me read the question again. Close the switch in number 2. Okay, yes, because according to this, let's go to number 2. Number 2 says, finally connect the free terminal of the resistor to the negative terminal of the capacitor through an open switch. Okay, it means that the switch is not supposed to be, it's supposed to be open, it's not supposed to be closed. Okay, it's supposed to be open, it's not supposed to be closed. So initially it's not supposed to be closed. It's now in number 4 that we need to close that switch. Okay, so that the resistor discharges through the voltmeter, so that the capacitor discharges through the voltmeter and the resistor. Okay, and then using the stopwatch, we need to record the voltage every 20 seconds. So the voltage of the capacitor, the initial voltage when time is 0 is basically, because when we connected the battery, we charged the capacitor. Okay, then now we now have to discharge it by connecting it to a resistor. Okay, and we are connecting it in parallel to the resistor. So we are connecting it in series to the resistor. Okay, with that there is discharging, so the voltage is going to drop. So after every 20 seconds we are reading the value. So basically, if you want to anyways, I think we are going to draw the setup later. So let's move on to plot a graph. So I think you know how your table is going to look like. Okay, I think you know how your table is going to look like. You're going to basically have values of the voltage. Make sure you you know the since you're taking this multimeter to the 20 volts, you see that it is 20 volts. So it measures to no decimal place according to what they are saying. So you cannot be having something like 15.5 volts, it's impossible. You cannot have 15.0 volts, it's impossible. You'll be having only a whole number of voltages. Okay, then the stopwatch, you need to know the precision of your stopwatch. Your stopwatch might be measuring to 2 decimal places. So since you're measuring the time after 20 seconds, on your table, let me just try to put a table here. On your table, you have values of voltage in volts and then values of time in seconds. So you write the values of the voltage. Okay, then for the values, maybe you begin with V0. V0 is the initial voltage of the capacitor. That is when you just start your stopwatch. okay, the initial voltage of the capacitor, what you read, that's your which is basically going to be the voltage of the battery, because you charge the capacitor using the battery before you disconnect it, and it's supposed to carry no decimal place according to the equation. Then if your stopwatch is to two decimal places, your first time should not be 0, it should be 0.00. This precision is very important. Then since you're measuring after 20 seconds, for V1 is going to be 20.00. It's not 20 but 20.00 if your stopwatch measures to two decimal places. But if it measures to one decimal place, it just be 20.0. If it measures to no decimal place, it's just going to be 20. So the next one is going to be what? 40.00. So be vigilant about the precision of your instrument. Okay, now this is already 15 minutes anyways. So let's now go to the plotting. So plot a graph of ln V on the vertical axis against T on the horizontal axis. So basically, we have to kind of have in mind how the graph is going to look like. Okay, so if we are charging a capacitor, the formula is the voltage is equal to V0 e to the power negative T all over RC. Okay, so if I take ln on both sides, ln V will just give me negative 1 over RC times T plus ln V0. I've rationalized. So if I plot a graph of ln V against T, I'll have a straight line whose slope is negative 1 over RC and whose intercept is the ln of V0. Okay, so I'm going to have a straight line. Now you see that the slope is negative, so it is downward sloping. So let me just try to wipe everything here. I believe you have already taken a screenshot. So if you want to plot, probably you're going to have something like this. On the vertical axis, you have ln V, okay? No unit because it's a constant, or you can write the ln of, you put bracket V in volts, depending on you. Horizontal axis, you have T in seconds, okay? It's going to be downward sloping, something like this. So that's how it's going to be. You can now easily calculate your slope by taking any 2 points on the line that are not plotted points. Okay, you find change in y over change in x, you get a value of s, your slope. Okay, now let's move on to the next. Number 6 says determine the slope of your graph. I've already shown you. 7 says the slope of the graph is given by s equal to, in fact, let me just write what is written there. So what I see there is s equal to minus 1 over a minus r times c. Use the values of s, r, and c to calculate the value of a and state what it represents. So normally I already showed you guys that s was normally equal to minus 1 over RC. You see, so just be comparing these two, you realize that your minus 1 is there, minus 1 is there, your c is there, c is there. Therefore a minus r must be equal to r. So a must be equal to 2r. Okay, so a signifies double the resistance of the resistor that was being, of the fixed resistance that was being used. So that is already a clue on how you're going to end. But you can also use a value, like the equation says, you use the value of s, of r, and of c. You make a the subject of the formula here. Okay, when you make a the subject of the formula, you get the value. Then you compare it with 2 times the value of your resistance. If they are almost the same, it means that you are in the right path. For the precautions, I think you know your precautions to take. Make sure the crocodile clips are clearly placed so that there is firm electrical contact and all those stuffs. So now let us see how to draw the diagram of your setup. So let me, I think I already drew something up, but let me try to draw a circuit diagram. Okay, so I'll need to erase this circuit diagram. So what we did was that for the process to actually occur, we have a capacitor, we have a switch which was closed at the end of the day. Okay, the switch was closed. Then we have a resistor. The other end of the resistor, we have the no, there was no battery. So I think this is what we have. Okay, then I think we connected the voltmeter across one end here and the other end here. Yeah, I think this was it, right? Yes, exactly. So this is it. So this is my voltmeter. It was measuring the voltage across the capacitor. So this is my resistor, here's my capacitor, and here's my multimeter. So I think basically this is our circuit diagram. Okay, so this is already 20 minutes. Let me see if we can go to stations. All right, so I think in the next video I'm going to do stations. So stay tuned for the next video.